Hi everyone, welcome back to Code Meets World. And before I get started, I just wanted to mention that my last video, which I'll link at the top of the screen right now, is me saying thank you for hitting 100 subscribers by doing a little bit of a giveaway. And if you go watch that video, you can see how to win an Amazon gift card. So back to this video, I am going to be working on the next problem in the math and geometry section, which is the +1 problem. So this is LeetCode number 66, and we are given a large integer represented as an integer array, where each value in the array is the ith digit of the integer. The digits are ordered from left to right. The large integer does not contain any leading zeros. We need to increment the large integer by 1 and return the resulting array of digits. Right. So basically we're just given a number. So this number is 123, but it's in an array rather than actually an integer. And we're supposed to return 124, just adding 1 to it, but keep the array. And this seems easy on these initial examples. But yeah, exactly. Where this gets challenging is when you have 9s. Because then you can't just increment it in return, you have to break that up into 1, 0. So let's hop down to the whiteboard and talk about how we can do this. Okay, so if we think about the algorithm, because that's all that we're going to run here is an algorithm, let's think about how we would do addition just normally. So if this was just 123, and we wanted to add 1, we would simply start at the ones digit and say, can I add 1 to this? The answer is yes. So we add 1, and we're done. Now when I said, can we add 1, there's one case where we can't really add 1, and that's if this was a 9. If the ones digit is a 9, so let's do a different example. Let's pretend we're given the number 19. When we go to this first one, if it's anything less than 9, we just add 1. But if it's 9, as we know from mathematics, we have to make it a 0 and then carry the 1 over to the left, to the tens place. So we could do that. We could say, okay, we'll make that a 0, and then we will slide our pointer over to the tens column and say, can I add 1 here? Meaning, is it less than 9? It is, so we add the 1, and we're done. Our values would have a 0 and a 2, and we're finished. So imagine we had a number like 999. It seems like our algorithm, again, just like we were doing normal addition, is we have to loop, and we need to loop until we find a value that doesn't equal 9, and then we add 1 to it. So for instance, if this number was 1999, we would change everything to a 0 that's a 9 until we get to a value where we can add the extra 1, and then we add it. Now if we truly are given a number like 99, we just convert everything to zeros. But if we get to the end and we haven't had a place to put that extra 1 yet, we can just toss it right on the end. Or there might be an easier way to do that I can demonstrate in the code. But I think this is pretty straightforward. I think we just do the math like we know how to do it, but we have to actually carry the ones like we were doing this by hand when we were learning how to add back in school. So I'm going to hop back over to the code and we're going to talk about how to write this. Okay, so now to write the code for this, I'm just going to implement normal addition like we would have done it when we were learning addition in school. And I think that's going to be all that we need. So hopefully this isn't too tricky. How we'll start is, like I talked about on the whiteboard, I want to start looping at the ones digit and then move backwards through the array. So as we usually write for loops, looping from left to right, I want to loop from right to left in this for loop. So that's going to be just slightly different if you haven't done this before. So we can say for I in range. So I'm going to start with the rightmost part of the array, which is the length of digits. And remember, arrays are 0 indexed. So if, for example, I wanted to do this array, I can't start looping at index 3 because that would be off the end of the array. I need to start looping at index 2. So I can say -1. And we want to decrement by 1 each time, so move to the left. And then we want to stop, and this is a funny convention, at -1. Because remember, when you're looping in Python, it is exclusive of the right-hand bound. So if I put 0 here, we would stop looping at index 1. So if I want to stop looping at index 0, I have to put -1. And an easy way to remember this is if you're ever looping backwards in Python, you should have this funny looking -1, -1, -1 syntax. So that's sort of how I remember it. Right, so starting at the end, the first thing I want to check is the ones digit less than 9? Because if it is, I just add 1 to it and return. So if digits I is less than 9, all we have to do is say digits I plus equals 1, and then we simply return digits, right? If the ones column is less than 9, I just add 1 to it, and then I can return the array as it is. If this is not the case, then it must be a 9. If it is a 9, I need to check, I guess, 2 things. The first thing I need to check is this the last value in the number? Meaning, am I seeing a 9 and it's right here at the end? If I'm seeing a 9 at the end, I just need to make it a 0? No, I need to make it a 1, and then I need to add a 0 to the end of the number. Let me show you what I mean. So if I equals 0, remember, because we're looping backwards, starting at the length, going until we get to -1, 0 would be the last value on the left here. So if I is that, and in this case we know, so we're seeing a 9, and it's the leftmost digit in the number, all we need to do is say digits I, so let's change this number into a 1, and then we're going to append a 0 to the end of digits. So does that make sense? If we see a 9 at the very beginning of our number, which is so basically if we see a 9 and it's the leftmost value, we're going to turn it into a 1, and then we're going to add a 0 to the end of our array. So that would change this from 9 to 10, or whatever number, into the correct next number. But there's one other case here. What if I've seen a value that's not less than 9, so it's 9, so we go down into this else. I is not 0, so we're just some other random place inside the number, and we see a 9. Well, in that case, it's easy. We just set digits I equal to 0, right? Because basically as we go through the number, if we see any 9s, we just need to make them into 0s, and then eventually we're going to hit a number that's less than 9, and we're going to add 1 to it. If we never hit the number that's less than 9, because the whole thing is just 9s, then we're going to do that trick here, where we change the last 9 into a 1 and add a 0 at the end. So let's go ahead and run this and see if it works. So that didn't work for the very last value, and which is 9. So mine outputted, oh, nice, it didn't output anything. Oh, I think that's because I didn't return anything. I think I need to return digits right there. Hopefully, maybe. Yeah, okay, there we go. Phew. So I don't think anything was actually wrong. I just need to return digits right there because I know I've hit the end of the number. I don't have to return anything here because we're not at the end of the number yet and we need to keep going. So let's go ahead and submit that. Yeah, great. So that has passed, and it's a pretty quick solution in terms of runtime, which is nice. And yeah, hopefully that makes sense. It's interesting to take a really simple concept. We all know how to add. And when you bring that into programming, you really have to think through it to get this right. So thanks everyone, and I will see you soon.